Right, so this is the week 11 workshop problems. Happy New Year, everybody. So I'm going to just record a single video to go through all of the questions on this worksheet. Importantly, this will really reinforce everything that was in the lecture. So if you haven't attended or watched the lecture yet for week 11, which was delivered by Natasha on Monday the 4th, go and watch that first. Okay, everything we do here is going to reinforce that. Okay, so secondly, if you haven't got RStudio working on your laptop yet as a local version, if you try to download it and install it and it doesn't work, we're past the point of no return now. Okay, use RStudio Cloud. I really need you to do that. If for whatever reason it's not working on your laptop, we do not have the capacity to help every person install that. We're doing that remotely. If you were all in the room and I could help you, one by one, I'd do it, but we can't do that this year. So if you can't, for whatever reason, something's stopping you from using RStudio as an install, use RStudio Cloud. Okay, and any questions beyond this point about installing RStudio are going to be met with the same response. Use RStudio Cloud. Okay, it will do everything you need to do for these workshops and for your test. Okay, right, so let's crack on. The first thing we're going to do here is I'm going to read this introduction bit here. This is just for fun. This R for cats, put that in there because it's actually quite useful. It's a bit silly, but it's useful if you're looking to learn a bit more about the semantics of R. This workshop, I'm just reading this now, uses an authentic data set from a piece of research on student test scores in Portuguese high schools. Okay, and the reason why I've chosen this data set, I appreciate it's not necessarily a relevant data set contextually for you. It's not about biology, but it's got a lot of demographic data. Okay, lots and lots. It's a large data set, and you can do a lot of hypothesizing about what's in there. So this will serve as a really good example, I hope. If you want to go and read the paper, you can. If you just click on this, it's a real piece of work, so you can read about what they did and how they did it. There you go. I have read this. I think there's even a table here with all of the names of the columns in the data set. So if you're wondering what each of the columns in the data set mean, go and read the paper. Okay, so the first thing we're going to do is we're going to create a new RStudio project. And so I'm going to use RStudio Cloud to do that. So let me get my cloud here. Okay, so I'm logged into my cloud. I'm going to create a new project. I'm going to pause this while this thinks. It takes a couple of minutes sometimes. And there you go. Here's my RStudio in a web browser. Okay. Right, so the first thing I'm going to do is I'm going to create a project which I'm going to call week 11. Week_11. And then I'm going to create a new file, which I'm just going to save as, again, week 11. Doesn't matter what you call this. Whoops. Right. And I believe that is all you have to do for 10.1.0. Okay. So, no, we're going to also get the data and extract that to our RStudio. Okay. So, let's go back to the problem. Let's go to the link above. So all the data set is here. So let's have a look at this. This is a real website. All of the information is summarized here. Here are all those column names again. I'm actually going to get the data folder here, and I'm going to download this student.zip. Okay. There you go, downloaded. Now I'm not going to open it. I'm going to go back to my RStudio. Here it is. Oh, no, that's not the one I was looking at. Where is it? There it is. Okay, and now I'm going to upload that entire .zip directory that I just had there. If you're using RStudio locally, what you'll have to do is you'll have to extract the contents of that directory to your R project directory. It has to be your R project directory, otherwise you're going to get errors, okay? Right, so here we go. Here is, I've actually done it twice. I'm going to use the original one here. Open and then open. And there you go. You can see you've got a whole range of additional files here. I'll make that a bit bigger. Down the bottom here, this is the one I actually want. If you just view the file here, you get all this nonsense. So that's just the raw data. I'm now going to read that into RStudio. Okay, so that was 10.1.0. This next bit, I'm going to go to my, zoom out a bit here. I'm now going to load that into a data frame. Now these are all math scores, or data associated with math scores for a student. Actually, let me just take a look at that data set again. If I go here, what I've got here in my data file, I've got a load of information about a student. Each row in my data corresponds to an individual student. I've got their school, their sex, their age, their address. I've got their family size, parental status, loads of really sort of quite personal information about these students. Whether or not they want to go to university, whether or not they're in a romantic relationship, data, okay? And the last three columns in this file correspond to their maths grades, okay? And these are the maths grades. So they've got the grade for the first period, the grade for the second period. These are equivalent to our semesters, and then the final grade, which is the average of that, okay? And that's from 0 to 20. So that's what's in here. Let me go back to my RStudio. So I'm going to read that data in. Let's do that. Let's label this as 10. This is now 10.1.1. Read data. So what I'm going to do here is I'm going to create a variable called math. I'm going to be British about it. I'm going to use maths plural. And then I'm going to use my good old friend read.csv, and I'm going to call, and I've actually told you in the questions here, do you want to use the student-mat.csv? So student-mat.csv. I'm going to do that. It's read it, but no, something's gone wrong here. I've got 395 rows, but only one column. And if I look on that, something has gone seriously wrong. Okay. Now the reason why that has happened is because in the columns in my data file, which is just a CSV, are actually separated by a semicolon, not a comma. Now R assumes a comma by default, but if it's not a comma for whatever reason, you'll have to tell R how your columns are separated. So there's an extra parameter to use in your function read.csv. Put a comma there. I'm going to put sep, which is pretty self-explanatory. It stands for separator, equals. I'm going to open up quotations, and I'm going to put a semicolon. I'm going to run that again. There you go. This time I've got 33 variables. That's better, isn't it? Here's my data. That's looking good. Right, all of those columns. Right there at the end, I've got G3, which is the one I'm going to be interested in for this workshop. Okay, so I think that was 10.2.1. Fantastic. Let's go back and look at my problems wherever they've gone. Over here. Now I'm gonna. Oh, okay. This is still 10.1.1. I want to actually remove all of the non-zero scores. So I actually want to remove all the zero scores. So I'm gonna discount any zero scores. I'm actually going to assume that those students didn't sit the exam, their exams. So I'm going to remove those by actually filtering my data. So to do that, I'm going to use, now I've said here to use the which command. I've done that previously in previous years, but that's actually quite complicated. So I want you to ignore this statement for now. and we're actually going to use this subset function instead. Okay, so let's do that. Right, so I want to create a variable which are maths not zero, non-zero G3 for G3. So I'm looking at students who haven't got a 0 score for their final score. I'm going to assign to that all of those rows that don't have 0 scores. I'm going to use this subset function. I'm going to call my original data frame, that's maths, and I'm going to put a comma in there, and now I'm going to put in my conditional statement. Okay, so it's my G3, and I want that to be greater than 0. Okay, so I put in my data as the first parameter here, that's my entire data frame, and then the second here is actually a conditional statement, and I'm saying I want to take the column G3, and I'm only going to put the rows that have a G3 value greater than 0 into this new maths non-zero G3 data frame. Okay, there you go. And if you take a look at that, now the first one here had 395 observables. This second one has only got 357. Okay, so there's about 40 students that have got 0 scores. I'm going to ignore those. Okay, right. Next question. 10.1.2. I'm going to do a box plot. Hooray! Okay, so you should be used to this by now. What am I going to ask you to plot? I want you to generate box plots that show the G3 scores with respect to the weekly alcohol consumption, right? And actually that's what this whole study was about, really, was about the impact of alcohol consumption on student performance. So we're going to use the box plot function, and I'm going to call up the data, and I'm going to call up the scores and the weekly alcohol consumption. And I think the score for the weekly alcohol consumption is a value of 1 to 5. Okay, so the students were asked, how do you rate how much alcohol you consume a week? 1 being low, 5 being high. Okay, so it's not the 1 to 5 doesn't correspond to any particular unit, it's just an arbitrary scale, and we've asked students to assign a number to that. Okay, so let's go back. I'm going to create a box plot. So box plot, boom, there you go. Right, and I want to look at the weekly alcohol scores. So I'm going to get the wealc. So actually, before I do this, if you ever want to know quickly the names of the columns in your data file, if you type names, maths non-zero G3, and you run that, you'll see they all pop up here. So I'm going to call wealc. I'm going to put a little tilde. It's not a hyphen, okay? Curly hyphens, a tilde. It's the shift and the hash sign for me. It'll be different for a Mac user. I'm going to call G3, okay? And then I'm going to put a comma there. I'm going to put data equals, and I'm going to use that data frame that I've created with none of the zeros in, okay? So maths no 0 G3, and I'm going to control and enter that. Okay, now I've done it. I always get this wrong. So I've actually got the X and the Y values confused. Always do that for this. So I was actually expecting 5 box plots based on the score, but actually I've got 20 box plots over a range of Y 1 to 5. So I'm going to swap these round. It's G3. So basically you've got to put your X coordinate in first, okay? Control and enter on that again. There you go. That's what I was expecting. Let's zoom in on that. That's what you should get. Now, I think these labels could probably need a bit of clarification. So I'm going to put an X label here of weekly alcohol consumption 1 to 5. And I'm also going to put in a Y label of G3 final test scores. Okay, and I'm gonna run that. There you go, that'll change that. You could put a title in there as well. I'm not going to do it, but you could do, there you go. You could put the title on as well. Okay. Right, so what we're now going to do is, I think, the next question. Let's have a look what it is. Yep, we've done that, 10.1.3. Based on weekly alcohol consumption, divide the students into two groups. So we're actually going to split them into two groups. Any students that rated their alcohol consumption as less than 3, we'll put them in, we'll call the low group. And any student that rated their alcohol consumption as 3 or greater than 3, we'll put that in a group we'll call the high group. And again, I'm going to use my subset functions here. I've actually given you these lines here, so I'm gonna cheat badly here and just copy and paste these in. The important distinction here is what I'm doing is I'm not creating new data frames. They are data frames technically, but what they are really is lists of numbers. So I've actually called the $ and the column at the end of it. So this is just going to be a list of numbers, okay? It's not going to have any of the other categorical information in. Let me just create those. Right, let's go back. So this is 10.1.3. There you go, and I'm going to run both of those. Oh, there you go. I need to use the correct name for that. I've actually changed the names of my variables between the video and the question, so be careful, okay? There you go, they're both there now. And there you go, they're actually lists or vectors in R of all of the scores. Okay, and I've used the subset function on my maths NoZeroG3 data frame with a conditional statement of weekly alcohol less than or greater than or equal to, and I've called the column for each of those subsequent data frames. Okay, right, that was that problem done, I think. Yes, right, the next thing we're going to do is I'm just gonna produce some basic descriptive statistics for those sets of data. Okay, and I'm going to use the Psych package. You don't have to. I think we've had a lot of problems with the Psych package on the local. I know it works in RStudio Cloud, but if you've got a version of RStudio download on your laptop, this might not work. Because what I'm going to do now is I'm going to install 10.1.4. I'm actually going to I think actually I've got that wrong. Install packages psych. Okay. There you go. Oh. Naughty. This. Run that. And in RStudio Cloud, you'll see this little red button pop up and it will actually install the package you need. Okay. I'm just going to pause that recording while it does that. And we're back. So it's installed that now. If I go to my packages, I can see I've got the psych there. I could click that to install it, to actually include the package in my script, or I can include the line library psych. Enter. Okay, and it's done that for me. Okay, so now I can run some descriptive stats on those two groups. So I'm going to write describe G3 low to begin with. Okay, and that'll spit out the number of people in that group, the mean, standard deviation, median, the minimum, the maximum, the range, which is the range between the minimum and maximum. I've also got the standard error at the end here. The kurtosis is a value associated with a normal distribution. I'm not going to talk about that. I've also asked you to determine the interquartile ranges as well. So to do that, you can do, I've forgotten how to do this. I think I do IQR G3 low. Okay, so that's the interquartile range. So on a box plot, that would be, if I run my box plot again, my box plot, that's going to be the difference between the bottom of the box and the top of the box. Okay. Now, if I just wanted to actually get the numbers of students within each of the quartile ranges, I can actually use another function which is called quantile. And again, G3. There you go. And that says, okay, from between 0, they were sort of between 0 and 25. They are 5, and then 25 and 50. There's 10, 50 and 75. There's 12. I think I'm saying that right. Yeah, that's your interquartile range. Okay, sorry, your quantiles. All right. Okay. I'm not really interested in that, to be honest. It doesn't really tell me a lot of information, and I'm certainly not going to ask you to do that ever again. So get rid of that. Just know how to do it if ever someone down the pub asks you. The pub. Right. Okay. Okay. Let's have a look. Let's go back to my questions here. Done. Done all that. 10.1.4 is done. Let's do 10.1.5. Actually, I technically haven't finished 10.1.4 because I've only done it for my low. You do the same for the high as well. Do the same for both of them. 10.1.5. Generate histograms for each of the two groups and overlay them on the same plot. Ensure the plot is labelled appropriately and includes a legend. I've tried to do this before in a tutorial and I failed miserably. So I know how to do this now. I looked it up. So I'm going to give you the right way to do this. Okay, first, so you should know how to make a histogram, right? So let's make a histogram of the low group to begin with, okay? So 10.1.5. Let's do, make it down a bit. Let's do, I'm actually going to save these as variables. You don't have to do this, but it's better practice to do it. Plot 1 histogram, a hist, and then, right, I'm going to call my G3. I'm going to do low first. Okay, if I run that, boom, I get a histogram out. That's great. Now what I'd like to do here is I'd like to actually overlay the seconds. Okay, now that's easy to do. You can do plot 2 histogram. Oh, hi. Okay, now if I run that, all it's going to do is it's going to replace my first histogram with the second. I don't want that. I want them to be on the same plot. So I can do that, and now there's a second parameter I need to use in my second plot if I want to do that, and then it's called add, and I'm going to call that as true. I'm going to run that. Okay, and you can see it looks awful because these are just block colors. So I'm going to change the colors in a sec so they're slightly transparent, and I can see that overlay nicely. But at the moment, I now know they're on the same chart. Okay, and on the top one, I'm actually going to change the X label G3 final test score. Okay, and I'm also going to put in a title, histogram of G3 final test scores for 2 alcohol. I'm going to leave that off for now. Okay, I should be a bit more descriptive there. Okay, if I was ever presenting that, I would be more descriptive. Okay, now what I actually want to do here, I could change the colors of each of these. So as any parameter in this hist function, I can do col equals red, and there you go. And I could also put col equals blue, and there you go. It overlays them. It kind of looks okay, but I can make that a bit clearer if I add a bit of transparency to those colours. Now to do that, I need to actually define those colours myself. So I'm actually going to define two colours here. Col1, I'm going to use a function called RGB, which is going to look for three values. It's going to look for a value between 0 and 1 for the red. So if this is my red, I'm going to call that 1. Okay, I'm going to call the other two 0. I'm also going to use another parameter called alpha, which I'm going to set as 0.2. That's 20% sort of solid color. Okay, so it's going to be 80% transparent. I'm going to do the same for a second color, which of course is going to be blue. So this time I've put the third value as 1. Okay, 0.2. Find that, and I'm going to replace these with those two colors. If I run that, there you go. Oh, something's gone wrong. Col1 not found. Oh, I defined it. That's 2 as well. There we go. And then the second one is Col2. There you go. So that looks a bit better. Actually, you can see it's nice that when these are overlapping, you get a third color here, which sort of indicates the regions of the overlapping. Right. Now, the last thing I want to do here is I want to add a legend, so that I know which of those distributions correspond to which group. Because at the moment, I know that the red ones are the low, and the blue ones are the high. Incidentally, I can see very clearly from the histogram here that the distribution for those with the low alcohol consumption is definitely shifted in score to the right compared to those who rated their alcohol consumption as high. So it's quite a good indication by eye to see the impact that parameter has on your data. I'm going to add a legend. I'm going to call the function legend. I'm going to the first in here is going to be I'm going to make sure it's in the top right. Oh, top right. And then I'm going to actually put in my two labels here. So I'm going to create a list of those. That's C followed by an open parenthesis, right? And my first label is weekly alcohol is less than 3. My second is weekly alcohol is greater than or equal to 3. Okay, and then finally I'm going to go fill, and what this fill is basically it hooks up the labels with the colors on your plot. Okay, so again that's a vector, and that's going to be col1, col2. Run that. There you go. Bada boom. Okay, was that all there was? It can't be. There's more to it than that. Let's have a look. Right, we did that. 10.1.6 postulate a null hypothesis that considers the differences in the mean G3 test scores between the two groups. Okay, so if you watched Natasha's lecture, she gave a really great overview on what a hypothesis is and how to make one, and how to make a corresponding null hypothesis as well. So I'm trying to test whether there's a difference between the G3 scores of students that are in the low and the high categories. So my null hypothesis is going to be there is no significant difference in the G3 final test scores between students who rated their alcohol consumption as low, 1 or 2, and high, 1, 2, 3, 4, or 5. Okay, so that's my null hypothesis. I'm actually going to write that down here. I'll cross it out later. There is no significant difference in the mean G3 final test scores between the students groups consumption. Okay, that's what I would do for that. I'm going to rub that out so you can form your own hypothesis later. Okay, now the best way to actually test that hypothesis for us is going to be the use of an independent t-test. So we're going to use an independent t-test when we are looking at comparing the means of two different groups. Okay, now that applies to a whole range of scenarios. If you've done the Titanic walkthrough, you will have used a t-test, I think. So all we're doing are, and actually the distinction here, and Natasha again covers this, is we're actually going to use a Welsh test in R. Very, very seldom do you get two groups where the variance of those two groups is equivalent. Okay, it's very, very often not the case. So we use a Welsh test, still a t-test, but it's relaxed that constraint that you need to have two distributions with the same variance. So with the Welsh test allows you to have a non-equal variance. Okay, and R actually assumes that by default. So we're going to do that t-test. So this is 10.1.5, 10.1.6. So if I was doing a t-test on these two groups, I would do t.test. Make a bit of space here. T.test. I put in my first group low, and then my second high, and I would hit Control and Enter. And in my terminal on my console down here, it's going to give me the t value of the Welsh test. It's going to give me my degree of freedom, which you'll notice is not a whole number, and that is to do with the fact it's a Welsh test, not a t-test. And it'll also give me the important one here is my p-value. Okay, now remember, what this p-value is the probability that the difference in the mean values of my two distributions are completely to chance. Okay, now the probability of that being true in this case is 0.004157. It's really, really low, and we set that threshold of 5%, 0.05. Anything below that, and we say, well, if the probability of that happening is so low, then my difference must be significant. So in this case, you would be rejecting your null hypothesis and accepting your hypothesis. Okay, you reject the null hypothesis that there is no difference between the two groups. Okay, if your p-value is less than 0.05. Okay, now I've thrown a bit of a spanner in the works down here at the bottom. If I go back here, what I should have done first is I should have checked that both of those groups are distributed normally. Okay, and that's important. That's a condition of you using a t-test. If you haven't got normally distributed data, or if whatever sample you've taken is not normal, then you shouldn't be using a t-test. Full stop. Okay, so we're going to quickly backtrack now and test that those two distributions are normal using what's called a Shapiro-Wilks test. What a lovely name. I think it's two names. One's Mr. Shapiro, and one is Mr. or Mrs. Wilks. I don't know whether they're male or female, okay? Right, so let's go back. To do those tests, I'm going to do it. Now, I do it on each of those groups in turn. I'm going to do Shapiro tests, and I'm going to call G3. Oh, no. Have I done that right? Yes, I have. Okay, now for this test, and this is, it's still a statistical test, right? So I'm going to get a p-value out of it, and for this particular test, I could make a null hypothesis, and my null hypothesis in this case is that the distribution is not normal. Okay, now so my p-value is basically giving me the probability that my distribution is not normal, and actually this is really, really low. Have I done this right? Probability that is not normal. probability that it is normal. Actually, the hypothesis here, my null hypothesis, is actually right. Now I'm going to go back and I'm going to get the notes out and I'm going to see what Natasha has said to us. Okay. Right. So here I've got the lecture notes. I always get confused by this. Okay. So it's okay if you do too. If you get confused, go back and look at your notes. This is what I'm doing now. Right. So the null hypothesis for the Shapiro-Wilk test is that the data is sampled from a normal distribution. Okay, so any p-value which is really, really low is basically saying that the probability that your data is sampled from a normal distribution is very, very low. So actually, in this case, for a p-value less than 0.05, I need to reject the null hypothesis. Okay, so in this case, in the case of our data here, where's it gone? There it is. I've actually got a p-value of 0.03. Okay, so my null hypothesis that the data is sampled from a normal distribution must be rejected. In other words, my data is not normal. Okay, now that has a huge bearing on what we did previously. It means now that we cannot trust the t-test because my data is not normal. Okay, I've only tested one of the groups here. You could do the second one. Chances are that that's not normal as well. There you go, I've got a p-value of less than 0.05. So no, that's not normal either. Now that means we completely throw out any conclusions that we've drawn from an independent t-test. Okay, now that happens all the time. Okay, it's okay, don't need to panic. There's usually always another test, and in this case there is a test that we can use, and this is not on the test. This is not. I'm not going to examine on you. You don't need to know this at all this year if you don't want to, but you probably will encounter it next year. So there's a test for any distribution that is not normal, or comparing any two distributions that are not normal, and that's called a Mann-Whitney-Wilcoxon test. Okay, and in R that's really, really easy. I've actually given you a link to that, a bit of reading on that in here. There you go. Mann-Whitney-Wilcoxon, often referred to as just simply a Mann-Whitney or even a U-test sometimes. And in R you call that using Wilcox test. And I'm going to put G3 high and G3 low. I'm going to run that. Okay, and this time it's still giving me a p-value of less than 0.05. So my original hypothesis that I used for the t-test, that there is no significant difference between those two groups, students who rated their alcohol consumption as low and high, because that I would still use that hypothesis, or that null hypothesis, and because the p-value here is less than 0.05 again, I can reject that null hypothesis. So in other words, there is a significant difference in the mean G3 scores of students who rate their alcohol consumption as low and those that rate it as high. Okay, and you can see that from the histogram anyway, pretty much. It just confirms what you kind of already know. Okay, so I think I've said too much there about non-parametric testing, and if your distributions are not normal, but that's always important to bear that in mind when you're making any test, that you satisfy all the conditions of that test. So for the independent t-tests, your distributions have to be normal. Okay, right. I think we've got one last thing to do, or was that it? That was it. Okay, so that was a bit long-winded, I know. I hope you can get through that okay. There is an extra section at the bottom, which I've called bonus. Do go and have a look at the rest of the data in that data file. And here I'm actually going to get you to make a scatter plot of the G1 versus G3 test scores as well. Okay. Okay, any questions, post them to the questions channel on Teams, or come to a workshop. And yeah, good luck. See you later.